All right, guys, today we're going to meet and talk about partial quotient. So your goal today is I can use a partial quotient strategy to solve a division problem. Another one of those super valuable skills that's going to keep going through 5th, 6th, 7th, 8th grade and beyond to help you. So it's really important that we're fluent in this strategy and we can use it well. Another really important part of the strategy is going to be your multiplication facts, because in order to use partial quotient strategy, you need to know your multiplication facts for the number that you're dividing. So the first step we're going to do is we're going to make a list of the first 6 multiples of 7, the smaller number, the number that's outside the bracket when you're doing your multiplication, or your division, excuse me. So if we were doing 7 into 325. We're going to make a list of the first 7 multiples of 7. So 7 times 1 equals 7, 7 times 2 equals 14, 7 times 3 equals 21, 7 times 4 equals 28, 7 times 5 equals 35. I'm going to stop there because I see my 35 here. And I know if I should change this into 7 times 50, it would be 350 using my power of 10 rule. And that's going to be larger than the number I have here. So I don't need to continue. But I can use these other facts over here to help me solve this problem a lot quicker. So I can see that 7 times 4 is 28. That would mean that 7 times 40 would be 280. I would just add that 0 using that power of 10 rule in order to figure out that 7 times 40 would equal 280. And that's going to help me get this 325 down much lower. So I'm going to do 7 times 40. 40 is going to go on the outside here. And I'm going to subtract 280. So 5 minus 0 is 5. 2 minus 8, I can't take 8 from 2, so I'm going to go and borrow. 12 minus 8 is 4, and 2 minus 2 is 0. I only have 45 left because I was able to use this to help me quickly get that number down. Well, I can see that 7 times 5 is 35. Well, if I do 7 times 6, I add 7 more to 35. That means that's 42. Okay, well, that's pretty close, so I'm going to use that again. So 7 times 6. I don't care about that 7 because that's the number I have over here. What I care about is the 6. Okay, that second factor is going to be the one that comes over. And 7 times 6 we knew was 42, so we're going to subtract 42, which gives me 3 left. All right, well, I can't put any more 7s into 3, which means I would have a remainder of 3. So R3. A lot of times I've been noticing that kids will do all this work correctly, but they forget about the remainder at the end. So sometimes I just put that first. And then I'm going to go and add the products I use, the factors I used to help me get my partial quotient. So 40 plus 6 is 46. So that means that 325 divided by 7 equals 46 with the remainder of 3. Those factors helped me a lot up here. Okay, it was easy for me to break this apart into smaller chunks without having to do 10, 20 different equations down here. So making a list of all those multiples first can really help you break down this problem faster. The first time I did the problem, I didn't do this. And instead of doing 7 times 40, I did 7 times 20, and then I had to do that again. So I ended up doing twice as much work the first time because I didn't make a list of all of these multiples. So let's try it again. We'll start with that same strategy, making a list of our multiples. So we'll start with step 1, make a list of the multiples, the number that is on the outside of the bracket. So we'll rewrite our problem. Get it down here a little bit so I have space. 3, 215. 215 divided by 3. I'm going to make a list of all the multiples of 3 until I get to a number that's close to 21, that beginning part of our number. So I know 3 times 1 equals 3, 3 times 2 equals 6, 3 times 3 equals 9, 3 times 4 equals 12, 3 times 5 equals 15, 3 times 6 equals 18, and 3 times 7 equals 21, right? Those two match up. So I'm going to stop there because I don't really need to go any further right now. So those are my multiples of 3 along the side here with my factors. I'm going to use those to help me solve this problem. So I know now that 3 times 7 equals 21. So that should tell my brain, using the power of 10 rule, that 3 times 70 would equal 210. So I'm going to use that because that's so super close to this 215. The 3, it doesn't matter, the 70 goes on the outside, and then I'm going to subtract 210. All I'm left with is 5. So super fast. I know that 3 can go into 5 one time because I see that 3 times 1 is 3. The next factor is 3 times 2 is 6. That doesn't work. So I'm just going to do one more 3 from 3 times 1. I'm going to subtract 3 and have 2 left. Can't do anything with a 2 and a 3. 3 cannot go into 2 evenly. So I have 71 with a remainder of 2. Okay. Again, I was able to solve that problem in 2 steps. Without that, it took me 4 or 5 steps because I wasn't thinking about the factors and the multiples that I knew for 3. Using these helped me solve it a lot faster. So yeah, it is one more step than maybe you were doing in the classroom before we left, but it is a step that really helps you solve it a lot faster. So think about these steps when you're solving your problems today for partial quotient strategy. Make a list of the multiples of the number on the outside of the bracket. So when we had 3 on the outside, we made a list of all the factors of 3 until we got a number that was close to these beginning 2 numbers. That helped us use the power of 10 rule. We knew that 3 times 7 was 21, so we knew that 3 times 70 was 210. We just added a 0, just like we added a 0 to the 7 here to make it 70. That helped us solve that problem super fast. Use those products to help you decide what equations to use and then solve. Don't forget about your remainders. Remainders are really important. They can make all the difference in the problem, especially with a story problem if you're trying to figure out how many boxes of something to get, and those remainders are really important. Okay, let your teacher know if you have any questions.